I hear you.
It's good to start the day.
I know. Well, Malik, I'll let you introduce yourself and your session, and we'll go from here. Thank you.
Uh, Thank you. Let me stop presenting. Give me a minute. So while I'm prepping, I'm getting back my presentation online. I wanted to introduce myself. I'm a cloud solution architect. I work for Microsoft, and I have the pleasure of starting the second session of today. I hope it's going to be a nice presentation. It's always tough to start after James Serra, who's our star, but we'll do our best. And if the presentation accepts to come in. So today, I'm going to speak about a use case that we have implemented at one of our customers, and I'm going to try to be as prescriptive as possible, and try to try to paint an overall picture of the business use case, what we were trying to accomplish, and how we got there, at least technically. I want this to be a two-way conversation, so don't hesitate to stop me. And who's going to be monitoring the chat for me?
Both Prashant and I are keeping an eye on it.
Okay, perfect. So please don't hesitate to stop me if there is any questions. I would like to answer them as it comes in.
You got it.
And I've seen a lot of my customers also joining today's call. So I say hi to them and thank you for your support and joining. To kickstart this session, I wanted to speak about streaming into Synapse. So whenever you think about streaming, you do not think about a SQL data warehouse solution. Typically, you think about maybe a transactional system or a NoSQL database that can ingest a lot of data very quickly, such as Cosmos DB or Azure Data Explorer for log analytics. But if you want to do some time series data, but typically when you think about real-time streaming, you should not, we would not think about Synapse Analytics. Before I start this session, there's a lot of confusion about what is Synapse Analytics and what Synapse Analytics mean. Synapse Analytics is just to make sure that we're on the same page. It's an end-to-end virtualized platform that provide multiple engines. Some of these engines are a SQL pool, which is our SQL data warehouse MPP system. The SQL serverless, which is more about an exploration tool that is going to allow you to query some of your data externally that lives in your data lake completely serverless and explore some of this data and do some initial transformation. I would say initial, because if you want to do more joins and heavy transformation, then we would recommend you to do something like SQL pool, which is our MPP system. And then finally, we have something that is called Spark, which is our Spark engine. It runs into Spark computes, and obviously you can run these engines. Obviously, you can run this for any Spark job that you have. So I'm not sure why my presentation keeps on shutting down. Doesn't want to open. So the use case for this customer was they needed to ingest data in real time. They needed to ingest data in real time and get into their BI report, which was Power BI in this case, which was Power BI. How many people have lost outage? So power outage. Whenever we think about outage, we're thinking about power outage. So they need to identify how many people lost power outage. Typically, whenever you lose power outage, typically this happens during a storm, if you have a winter storm or during extreme weather condition, or it may happen due to human error or anything of this sort. So customers want to find out, and even the executives within the company, is how many people are losing real time power outage. And typically, whenever you have a storm, you have people that start losing power at a rate of 30,000 to 40,000 a second, because the grid are started to breaking down, and then everyone is getting disconnected at the same time. So whenever you're ingesting this amount of data, you need a system that will be able to load at least, we're speaking about 30,000 transactions a second, at least. And usually a storm happen from end to end. Usually a storm happen from zero. It goes from 0 to 45 minutes if it's extreme storm or a hurricane or anything of this sort. And then this is where you're going to see the bulk of people losing power outage. So having visibility of how many customers have lost power outage is extremely important internally for the company itself, but also externally. For instance, if I've lost power, I would like to know if my neighbor have lost power. I would like to know if I am the only one that I have lost power, or how many people are affected in my neighborhood, and so on. So it gives you visibility. If you can also provide data to the yes. So what's the Oracle piece? So we'll get to there. So let's continue a little bit more on the use case, and then I'll answer specifically on the question that was asked about Oracle piece and how did we get the data. So this really is a use case that we were trying to solve. When we put the architecture together, what we have done is we have decided to load the data using something that is called Event Hub. Event Hub is our streaming, is our event messaging layer that is designed for ingestion of big data workloads, and it's going to allow you to process this big data workload with something that's called Azure Stream Analytics, that it does the processing and the transformation of the data and lends this data into our Synapse Analytics platform. Now, Stream Analytics has multiple connectors. One of them is Synapse. It has other connectors for Cosmos DB. It has another connector for SQL database, and so on. So the combination of Event Hub and Stream Analytics gives you an end-to-end event platform with transformation that is going to allow you to transform your data, lend this data into multiple different output. Our use case was to use Synapse Analytics. The reason of why we picked Synapse Analytics and an MPP system, because you're loading data from multiple utilities, and you're not loading data just from one utility, one table. So after you load all of this data, we needed to do some joins, and we needed to bring some of the data together to be able to build up these reports. So this is why it was important for us not only about combining this data that Event Hub and Stream Analytics can do, but once it lands into our transaction, into our MPP system, that we can take advantage and do some of the joins between the different data points that are being loaded into our MPP system. So now it's getting loaded in real time in Synapse Analytics, but now because it's landing into the SQL pool of Synapse Analytics, you can efficiently and in near real time do these joins very quickly. We know with the NoSQL database, joins are, you may be able to work around joins, but it's tough and you need to do a lot of different hoops. In an MPP systems, it's inherent that you can do joins, indexing, caching, and workload optimization, and a lot of different type of software optimization that you can take advantage of, that is going to allow you to deal with this large amount of data, but also partition this large amount of data to be able to present this large amount of data in near real time. Yes, we're still in slide number 2, and speak more about the architecture, but I just want to pick why we took MPP system on this case. We were ingesting data directly from an Oracle system, which was a non-prem system. So we did not deal with OCI. It was coming from an on-prem system, and we dealt with Oracle Golden Gate that ingested this data from Event Hub. Event Hub is a solution similar to Kafka, but Kafka is a little bit different. So you have Apache Kafka, which is an open source technology, and you have also Kafka from Confluent, which is based on Apache Kafka's open source technology. Hub is based on something that is called Apache Pulsar, which is really a push framework. So you still have the concept of subscribers and consumers, but it's a little bit different architecture, and get into it a little bit more into later stages. Okay, so this is really the use case. So the use case was how can we stream data immediately and understand how many people have lost outages in real time. Doing so within 5 minutes or 10 minutes is easy, but how to do this in real time and joining data from different sources, from different locations. This is a tough part of it. So you're joining this data from different tables, and this data is coming from different types of schema. So you need to do some types of transformation, and you need to do all of this in real time. So how can you do it? So after doing this POC, what we have identified is it was extremely important. So we have identified that we were being able to land the data end to end from the on-prem system, which is Oracle database, using Oracle Golden Gate, going through Event Hub, then Stream Analytics, in less than 10, and landing the data into a SQL pool less than 10 milliseconds. I'm speaking a SQL pool. So in MPP system, there is no MPP system, and I challenge you, there is no MPP system within all of the different MPP systems that exist today that can land the data as quick as Synapse has done. A lot of them claim that they can do near real time. Usually, typically, it's minutes. Within Synapse, we're speaking about 10 millisecond landing data, and we're speaking about 40,000 requests a second, 50,000 requests a second. So this is a volume of data that we're speaking about. We were able to do the transformation of the data. So not only cleaning the data, identifying if there are some missing data point or anything of this sort, but joining the data, so heavy transformation, and bringing different sources all together to be able to provide one common report. The slowest query was 2 minutes 3 seconds, which is impressive, and this shows the data in a Power BI report. So you're showing this data end to end in a Power BI report. This is how quick the Power BI report was able to refresh. The outage data, what we have tested is customer. So we've done a storm simulation where customers were losing data at 500,000 customers within 3 minutes. Then we did another test for a total of 1,500,000, so 1.5 million customers that lost power. So what this means, it's sending approximately 40,000 to 50,000 events in 15 minutes every second. So 50,000 customers that are losing power. So these are events that are hitting our databases from different utilities opcos that are hitting our databases immediately into and going end to end into Synapse Analytics. And this is where we were able to provide how many have lost within the slowest query was 2 minutes and 3 seconds. And then, of course, obviously, we provided visualization, and obviously, if it's streaming, you can do it immediately. In this use case, we didn't use streaming, but we could have done this. And obviously, we've encrypted the data end to end, and we've implemented security. More than happy to deep dive into this in the later stages. So if we review all of this, what this really means is that the solution was really focused on 3 parts of it, which is the ingestion part of it, which is Event Hub and Stream Analytics. Then Stream Analytics can do some transformation of the data, but then because we needed to do some heavy joins and some updates and deletes and some other types of work, we needed to use an MPP system. This is where we picked Synapse Analytics, and finally we presented back the data to our visualization, which is our Power BI reports. Okay, so this is a use case. Now let's go back to the architecture. So how the architecture looks like. Today, when we've tested all of this data, we looked at Power BI. We looked at Oracle. This is the on-prem system, and Oracle and on-prem they had an Oracle Golden Gate. So we've decided to use Oracle database and then Oracle Golden Gate and we didn't change anything that was on-prem, so we kept the infrastructure as is, and we sent event directly to our Event Hub. Event Hub, you want to think about Event Hub similar to Kafka, but the difference is Kafka is more a monolith application, monolith architecture. What this means is it owns the nodes. So whenever you ingest data into Kafka and you have consumers that are consuming this data out of Kafka cluster, the consumers commit to a partition, and that's it. And they can't go beyond partitioning. Within Event Hub, we have you can be a bit more you can be a little bit more refined, where you can where you have segments within partition, and each consumers can share multiple the same partition, and the ownership would be under segments. So it's going to allow you to do it's much more flexible, where it's not a monolith application, but it's a tier application where we separate the broker from the gateway and from the storage. So this gives us a lot of flexibility in terms of having multiple consumers being able to use the same partition within Event Hub, which is a big differentiator. That's it. You need to scale up. You do not need to rebalance your partition. You can scale up with Event Hub out of the box and just add additional nodes, because the broker and the gateway and the storage are all separated. So this gives you a lot more flexibility. So Event Hub is a big data is a big data event streaming technology that has also built-in connectors that is going to allow you to connect directly to stream analytics, that is going to be able to create outputs immediately to different stores. In this case, we have Synapse Analytics, but you can create also outputs near real time to SQL database, to Cosmos database, to Azure Data Explorer, to Azure Functions, to Logic Apps, and so on. So there's a lot of different connectors and a lot of flexibility. What's good about Event Hub and Stream Analytics is that it integrates end-to-end with the Azure platform. It's a cloud-based solution, meaning if you're dealing with Azure Active Directory, this is all going to be inherent. If you're dealing with Azure monitoring, you're going to be using all of the same technologies that you have been using for all of the technology. It's cloud-based, so cloud-based solutions and so on. So this is really at a high level for Event Hub and Semantics. After you land all of this data into Synapse, so if you look at my screen, into Synapse Analytics, which is so Synapse Analytics is over here. So we were able to do from here to here in less than 10 milliseconds. This is how we landed the data. Then we did some transformation of the data, and we brought in multiple. So because in these cases we were receiving from 6 different sources, 6 sources. So we needed to transform the data into one common big tables and do some type of joins and cleansing and making sure that we're using a common schema and on, then present back this report to Power BI. So this is why an MPP system and real time that provided us this mechanism to be able to do all of this. Just one piece of it. Obviously, also we integrate within Synapse, and this was another big factor of this architecture, is that we integrate with Synapse Azure Machine Learning Service. So now you can forecast data to identify why did they lose power? What was the reason before? What was the reason? Did some kind of resistors break? Did some type of wiring? It's specific to a neighborhood. How can we get how can we get the contractor repair this hotspot quickly? How can I identify where is the hotspot quickly, and all of the different variables that leads into this. So this is why when we think about Synapse, we need to think about the integrated end-to-end solution that we provide with Synapse. When I started this conversation, I was speaking about SQL serverless, about SQL pool, about Spark, all under one technology. So power behind this is that you can share the data across these different clusters, and this really helps. And then you can take advantage of this data and do machine learning immediately on top of this data using the same platform, which is Synapse Analytics. And guess what? You can do also you can do data catalogs, you can do data quality. All of this integrates within our Synapse Analytics platform, which is our purview, which is our Azure Purview solution. And I'll get deep dive a little bit more into this. But let me pause because I have seen that there are some questions about the architecture. Tim, go ahead and ask your question, please.
I'm sorry, I got 2 here in the window. One we'll ask at the back, but real quick, you talked about the traffic shaping you did from the on-premises without an express circuit. Did you do this migration over the weekends? So that's just kind of a comment type question.
Yeah, so this simulation was done in a weekend, but we did simulate this workload in a weekend. Remember, what we are getting over here was completely a new solution. So it's not it's not a solution that was built on it's not a solution that was built that was running in production or anything of this sort. What was running in production was this. So this is what we did. This is why we did this over the weekend, not to add more load on the on-premise system. So yes, and the average ingestion rate from on-prem to to Synapse Analytics was at a rate of 4 megabytes a second.
Gotcha.
Does this answer your question?
Yeah, yeah.
So,
Thank you.
yeah.
And we got one
What
more.
was the second? Yes.
We got one
go
more.
ahead.
So you talked about 40K a second transactions coming into the event
Yes.
hub. What was the volume going into Synapse? Was it the same volume of data stored, or was there significant aggregation?
40K. Same. It was even more because you're getting this from six opcos. So 40K was was the average ingestion rate. You could have asked that why not do Power BI, go from Stream Analytics directly to Power BI, because Azure Stream Analytics is also can do some transformation. Yes, maybe not optimum for Jones, but it can do some limited transformation. But we took out this route immediately because, as we know, I'm sure that every one of us here in this call, I'm sure that have dealt with power outages. Some of the power outages, I never had this, and I hope that no one else also has this. But some of the power outage can be beyond 7 days. So what Schematics can do is a 7 days window. But if anything that is beyond 7 days, and you need to have some data with some history. This is why it's important to have some system like an MPP system that can deal with this kind of volume of data. Okay.
Thank you.
So this is really at a high level. So let's look at what was pre-Synapse. Pre-Synapse, you had you had different components, and all of them are solutions that are divided, meaning that if you want to do ingestion of the data, you have something like Azure Data Factory, or this for batch ingestion, or you have something like Event Hub for real-time ingestion. If you wanted to clean your data or do some transformation of your data or machine learning, then you have Databricks or SG Insight. And then you have our Azure SQL Data Warehouse, which is now known as SQL Pool. If you wanted to do an MPP systems and be able to do BI reporting for enterprise layers and be able to scale, distribute your data into multiple nodes. So you had a lot of different pieces, different technologies that you need to integrate all together. Headache to be able to I'm sure that whoever went to a production, it's really silos. So you need to be able to take care of this system, and then run Azure machine learning servers, and then figure out the authentication mechanism from Databricks to Azure Data Lake storage. And this is not usually very straightforward for whoever has worked with this. As also load the data from Data Lake to Synapse. So there's a lot of data movement that is happening. Duplicating the data, replicating the data is a headache. You want to do a lot of this data movement. This is why we look at something that is called Synapse Analytics, which is an integrated end-to-end platform that brings all of this together under one platform. Under one solution, and now you have this unified solution. You're going to tell me, oh, okay, Malek, this is Swiss knife. You're trying to bring everything together. No, Microsoft is the best in SQL. I'm sure we have been into technology for 30 years, and we had an MPP system. Yes, before SQL Data Warehouse, so we have a lot of experience with MPP systems. So SQL, we have a lot of experience. MPP systems, we have a lot of experience. Spark, we have our partnership with Databricks. We have worked with SG Insight. We have a lot of experience. We brought in the best of the best, all of the best technologies under one platform. So Spark, SQL, SQL, and ADF, and machine learning, and data catalogs, and also provide. James Serra was speaking about data models. So we have our templates, our data templates, which is which was known initially as common data model, where we provide templates out of the box for industry templates that you can take advantage of, and we have tools, neither data workbench editor similar to Irwin, if you want to think about it, and all of this you can work it out from this one integrated platform. So it's simplifying the solution. And now you have to deal with security. It's not, you don't have to deal with security, and you have to deal with, you have to still connect to your on-prem system and to the external system, but you have to do it once. You don't have to do it 3 times, 4 times, or 5 times. The movement of the data is extremely important, because now you move your data only once. You don't have to replicate your data. Data movement, ETL jobs is expensive. So this is simplifying the solution. This is the vision where we're building this unifying experience to reduce the amount of work that someone needs to do to be able to manage a platform end to end. And obviously, this platform would not work well if it does integrate with CI/CD, Azure DevOps, management, monitoring, and security end to end. And we know Microsoft really, is one of the best, if not the best, in security in terms of authentication, authorization, Azure Active Directory, and data masking, column level security, role security, and so on. So we do provide a lot of different technologies around this. So how do we look at, so when I think about Synapse and think about an end-to-end platform, I think about a virtualized end-to-end platform where you have a poly engine, so meaning you have your Spark pool, you have your SQL data warehousing pool, and the SQL data warehousing pool can be a SQL serverless or can be SQL pool. SQL serverless, you want to think about it as exploration engine where you can query data directly over the lake. And SQL pool, you want to think about it as an MPP system, and think about Synapse also as a virtualized platform, because you can now Synapse links. James Serra has shown just Synapse links. You can connect directly to your AML. You can connect to Power BI, to your SQL database, to Cosmos, to all of this out of the box, and you can see all of this environment under one solution, which is Synapse Analytics. And all of this is going to be able to consume the data into something that is called Azure Data Lake Storage. And you're going to see me refer to common data model. So what's a common data model? You want to think about it as typically whenever you land data into an Azure Data Lake Storage, it's going to be a bunch of files. So what Microsoft have done is, instead of having of landing data in files, we've said we're going to implement a common data model. So data model, you want to think about it, it's giving a representation similar to, it provides what are the entities that lives in your files, what are the different types of metadata that lives in your files, and it gives you information about your file for you to identify what are the schemas that are being used in this file, and something that's called the common data model. And this is what we provide out of the box. So now Synapse integrate seamlessly with your application data, with your transactional data. So application data with something that is called Synapse Link, that is going to allow you to bring your data directly from Dataverse. And so Dataverse is going to connect with your Dynamics application, your SAP data, your Oracle data, and so on. And it's going to allow you to land all of this data into a common data model. So what's common data model? It's going to give you a structure of the data. It's not just going to be files living into your data lake. It's going to have a representation through something that is called the manifest file, that is going to tell you what are the entities in these files, what are the different columns in these files, and so on. So it's going to give you structure of these files. So this is what's the common data model. And guess what? This common data model is understood out of the box by Synapse SQL pool and so on. So you bring in your application data. Then you can bring also in real time your Cosmos DB data through Synapse links, your SQL Server 2022, like James Serra has provided. And finally, you can also bring in your Azure Data Explorer, which is your operational data. So through this virtualized platform, you're bringing not only your analytic data, but we're combining all of the different types of data: analytical, transactional, application, operational, and semi-structured, so Cosmos DB and so on, all under one platform in end-to-end solution. And this is what differentiates us from everyone else in the industry. Everyone else is trying to play catch up in terms of building this integrated platform. Guess what? We now ingest data in near real time in Synapse. And this happened a year and a half ago, this POC. So it's not something new. So this technology is already mature in terms of maturity, because knowing how fast technologies are moving into the cloud and how new features are being added extremely fast. In near real time, you're getting this data. The second piece of it is you're building this integrated platform. So you're consuming the data from something that is called common data model that is going to have data model, industry data model available for you. And I'll show a little bit more about the data model. I know, Tim, you have a question, but I want to finish out the ideas and give you the questions. And then you're consuming semi-structured data, you're consuming Dataverse, application data, operation data, all under one platform. I'm going to pause. I know there are a lot of questions, so let's take a little bit some of the questions.
Yeah, so this one is, how do you do the software deployment within Synapse across DTAP environments? Is it heavily reliant upon scripts?
So we have CI/CD. I'm not sure if I'm going to answer this question correctly, because I'm not sure if I understand the question correctly. But any software development is going to be dealt. It's similar to a CI/CD platform that we would do, and depending on the on what kind of software development we're doing, there's going to be multiple options that a customer that someone can have. That someone can take advantage of. So that if there is a follow-up on this question, I would like to hear it. But while I'm waiting for the follow-up on this question, I wanted to turn away a little bit from the slides and show. So this is a workspace that James was showing. So this is where you're ingesting your data, you're exploring your data, you're visualizing your data. This end-to-end platform that is available where you have your workspace. Now you're sharing your data across the lake databases. So the lake database are data that you can bring on from and build data models. So you can look at data templates, database templates, and let's say that you are at you're a consumer good company. Okay, you click consumer goods. It's going to bring on data models that you can start editing out of the box. So let's say that you want to build a data model around contracts. You can say, I want just agreement of sales or something of this sort, and then I want to bring also bill of sales, and I want to bring the close of sales. So you can start building this, and it provides you. You can see. So let's pick. So it provides you multiple tables. You can you can put the relationship together. You can edit these tables. You can change the column names. You have a lot of different ways you can look at the relationship and start building relationships between these different tables, or you can use the relationships that are available out of the box for you. So if you look at over here, we have a consumer goods package model, and you can take advantage of this out of the box. So if you look at this, we minimize a little bit this, and these are some of the relationships. And obviously you can click create a database, and after you create this database, you can start. It's going to be saved into your Azure Data Lake model, into your Azure Data Model, and into your Synapse Analytics, and you can start editing this data model of the box for you, and changing the column names, description of the names, and so on. So this is one thing that you can do out of the box, differentiate us from everyone else. After you create a data model, you're going to have similar tables, as you can see over here. So let's go back and let's look at one of my table. And you can start querying some of these tables out of the box. So you click over here and you can select 100, and this running serverless. So you get just charged for what you use. Whenever, so there is this misconception of when you run Synapse, you're going to get charged. It's going to be extremely expensive. No, if you do not use the system, you're not going to get charged. If you're not using Spark, if you're not using SQL Serverless, you're not going to get charged. If you're running SQL Pool, you can pause it whenever you stop running. But of course, if you pause it, you're going to lose the cache. So you need to you keep this in mind. But if you're pausing it, you're not going to get charged. You only get charged for storage, and we know storage cost is extremely cheap in the cloud. It's something that you're not going to worry about. So now I just run a table on my external data lake. All of this lives in my Azure data lake storage, does not live in a subsystem, in an MPP system, does not live. I'm querying data directly that lives in a data lake storage in less than 9 seconds. If I want to do Spark on the same data, so I can do a new notebook, I can do a frame on this, and I can run this Spark job, and then it's going to run the Spark job for me also, which is independent from my SQL Serverless. Now, if I want to do SQL Pool, which is MPP system, I have it running now and can also do a SQL Pool, which is my MPP systems, all under one platform. Now it links the data immediately. I am changing. So I have my blob storage, my Cosmos DB, my data lake, my ADLS Gen 2, my integrated data set. So I have a lot of different data sets. I can also link this data to an external data set. So I have Azure Data Lake Storage, Cosmos, Azure Data Explorer, and we have a lot of new connectors that are coming that was announced at Ignite SQL Server 2022, and other connectors that are coming. That are coming. Now let's say that I want to do something else. So you see history. I know that I have a table that is called history. So, and you see this is called purview. So now I'm integrating all my Azure purview, so my data catalog, under an end-to-end solution, and click onto purview. I click into purview, and now I have information about my table. What is my table? How did my table get created? So it tells me history is a Azure dedicated SQL pool table. I look at the properties of this table. It got created in October 20. It gives me some information. This is what the schema is about my table. It tells me lineage. It provides me the lineage out of my table end to end. And it gives me also the related information of this table, all under my end-to-end virtualized platform. Now, let's say that I want to do something completely different, and I want to go to my to this, and I want to run machine learning. So now I can train a new machine learning model, and I can do classification, regression, time series forecasting directly, immediately out of the box from Synapse, or I can bring on my cognitive services, so predict with a model, and I can do anomaly detector, sentiment analysis, and a lot of the cognitive services immediately with Synapse. So you can see the breadth and depth of why Synapse and why a lot of our customers are picking Synapse, because it's an end-to-end platform that provides an end-to-end solution for you, and it provides not only the end-to-end solution, but it provides also a solution that is going to allow you to integrate forecasting, integrate all of your different data sources with something that's called Synapse Links in near real time, and also ingest this data directly into the platform. Extremely important, extremely big differentiator, and we have been working on this. So it's not something new that Microsoft has been doing this, but they have been working on this for the last couple of years now. Okay, and when we speak about couple of years, we know that couple of years is a lot in the cloud world. So I'm going to show you also one thing. I've spoken a little bit more about stream analytics and ingesting this data. So what we have is stream analytics. Stream analytics is going to allow you to ingest the data in near real time, and it provides you multiple connectors. You can see my connectors in this case was a SQL database, a Synapse Analytics, and a Cosmos, and a Cosmos. In fact, over here, I believe it was a Postgres, Synapse, and Azure SQL database. So you can see I have three kinds of different solutions where I am ingesting data directly from my event hub for three different data sources. So this is why we like Stream Analytics, because it has all of these built-in connectors that are available for the cloud and built for the cloud. So these are the connectors that we have available: Postgres, Synapse Analytics, ADLS Gen 2, Cosmos, Data Lake Storage, Event Hub, Power BI, Service Bus, SQL database, and table storage. And obviously, you can build your query. In this case, my query is an easy query that I'm selecting just 4 or 5 different data sets, and I am ingesting this data directly into my output data. In this case, the output data I had 3 output data, which is Postgres, Synapse, and SQL Pool. Yeah, go ahead.
Sorry. There's a little question here. I don't know if this overlaps, but can you please show the overall architecture diagram again?
Yes. Which is an amazing solution for the next slide.
Yeah, and then one more question. There was one about,
yes.
Can you show the real-time monitoring from end to end of how this worked? I can't imagine one person doing this unless they're highly skilled.
No, you can do it low-code UI approach, and we have templates for this. It's very straightforward. You don't need to be. Anyways, I'll take the second question that in 2 minutes. But let's speak about the first questions. This is the overall architecture. So let's remember, we ingested data directly from Oracle Golden Gate. So let me make sure my pen works. Okay, so Oracle Golden Gate to Event Hub, Stream Analytics. We send the data immediately to Synapse SQL Pool, and we landed the data into our Azure Data Lake storage. And then we used purviews that I have shown on top of Synapse to be able to do a data catalog, data lineage, machine learning to be able to forecast the data. And then we presented this data back in Power BI. So if you think about it, why did we use a SQL Pool? Because we provide this end-to-end virtualized platform. So now you can integrate your application, your semi-structure, your monitoring, transactional, all data under all one platform. This is one piece of it. And also it supports the new paradigm architecture. And there is a lot of new paradigms that are being built today in the cloud. You have data lake, you have data mesh, you have data fabric. And guess what? Synapse is going to be able to support all of these different paradigms because it provides a central tools for all of the different teams. Whoever is the owner of this data, doesn't matter who is the owner of this data, doesn't matter. It's going to provide one central tool for every person that is owning this piece of data to be able to run this data without moving this data. And because we know movement of the data is extremely expensive. So without movement of the data, and it's going to provide with the integration of purview, it's going to provide it's going to provide you visibility, policy, and a lot of different types of solution that is going to allow you to correct access to the correct people at the correct time. So this is what it does out of the box. and Microsoft have used a low UI approach mechanism to be able to do all of this. So now the second question was about how do we how did we run this end to end? So what I have done is I have my event hub. So I had an event hub already configured, and the art template to be able to do so. So it's all in the it's all in our Microsoft sites. You can just use a template. So I've implemented a template that is used. So I landed the data. And Event Hub provides also Kafka endpoints, by the way. I've built a template. I've used .NET to build a template out of the box. All what I have done is, and by the way, you can see it's running. So my requests are running even today. So I did some run today. Anyways, so this is my event hub, and I will show you some of the templates we have. So event hub, let's look at to see if we have something that is nice. So this is an example of a template that we have. It shows you how to ingest data at scale using stream analytics. It's an end-to-end. All what you need to do, repose this, and then you can modify it for your use case, but it does it for census data. And all of the code exists. After you do all of this, you can use stream analytics. As soon as you use stream analytics is going to allow, it gives you this UI interface where you can say, okay, what ID I want to use, what columns I want to use. It gives you an input preview of your data, and then you can connect the output. You can connect the output of your data, and in this case, I've used Synapse Analytics to be able to land data directly into my Synapse Analytics. As soon as you land the data into Synapse Analytics, it's going to create a SQL database table. And then in this case, this is my SQL database table, and I can run a query directly against my SQL database table. And you can see I'm running directly immediately a query, and that's it. It gives me some information about my template, about my census data. So you can see, in fact, this is about an e-commerce website that I had to deal with. It tells me item ID 274, that this is a discount number, this is a thing. So this is really the end-to-end solution. And then obviously you can use Power BI to be able, so if you go back over there, and this without even leaving Synapse, you can look at your Power BI data sets, and you can look at some of your Power BI reports immediately from Synapse Analytics. This is why you see Microsoft is building this end-to-end solution that is not only a virtualized platform, but also provides you the compute, the separation from storage to compute, the common data model, the industry data models that you can take advantage of, bringing all of this data together under this one solution. And it tells you at the end of the day, you know what, customer, worry about your query, and we're going to worry about your platform, and we're going to optimize your query to make this query run optimally, regardless if it needs to go to a Spark engine or to a SQL pool. And guess what? We're not going to charge you Spark or SQL Serverless or SQL pool. We're going to charge you for what you use when you use this. This is what really it provides Synapse out of the box. You have so through my quick presentation, I have seen I have done this end to end without even leaving my my Synapse Studio. I'm doing all of this within Synapse Studio. I want to show one last thing. You can also ingest data directly, and we use ADF behind the scene, same technology as ADF, and you can copy data directly if you want to do batch directly from Synapse without even leaving Synapse. So you can create a connection. Let's say you want to copy data from from a MySQL database or from Postgres or so on. You create this connection and you copy data and you then this data back and you can create some type of pipeline. And I have multiple pipelines that you can look at. And so this is one of my pipeline. I have a data flow, so let's look at my data flow and so on. And data flow is going to allow you to do transformation and it runs a Spark engine behind it. So if you, these are my data flows. So an example of a data flow is going to allow you to so this in just 8 columns. It does a filter on 8 columns. It does a conversion. It's all it does. It derived column, it adds a new rows, it do all of this. This is an example of an SCD type of data, so slowly changing dimension. I'm not sure if you're dealing with slowly changing dimension, but this is, we have template for this if you need to deal with this. I know we are at 10:55, which is Central Time, 11:55 Eastern Time. I'm going to stop. Tim, thank you so much. I know that there are some questions.
Yeah, sure. Let's and thanks, Malik. Let me, I'll hit them from the top to the bottom here as best I can, guys. There's one about
so there is one question: how these customers, how these templates can be shared outside with the different tenants. Today we have something that is called Azure Data Share that is going to allow you to share this data outside to external customers. And Marat, I can take this as an offline with you, and I know you personally, so I'll take it as an offline with you, and we can deep dive a bit more into it.
All right, I'll just go backwards. Are you reading the questions? If you're reading the questions, then I'll stop.
No, I'm not. I just read the last question.
Okay. So can Synapse convert code from PL SQL to T SQL?
No, we have some tools, but we don't have something that we offer seamlessly.
Gotcha. Is there a schedule for availability of Azure Stream Analytics in the Azure Government Texas data center?
Is
it on the roadmap?
I need to check. Can we write down the person name and send me an email? And can you send me an email on this and I'll get you the exact dates? Please send me an email on this. I think it's Damon Hill. Damon, you have my email, malek.el@microsoft.com. Send me an email on this and answer back.
Yeah.
So SSMA can do Oracle EL to SQL to T SQL. Yes. So this is one way. So we have tools. So to mark price point, yes, we have tools to be able to do this, but it will do 70% or 80% of your code. There's still some manual work that needs to be done, but SSMA is an amazing tool for you to start doing the code and make it much easier for you. Any other questions?
Yeah. What is the cost of this solution? What are the most expensive components in it?
SQL pool, SQL data warehouse. Whenever you're running the SQL pool with an MPP system, is going to be the most expensive piece of it. But for SQL serverless and Spark, if you use them, you do not pay for them. And if you're posing SQL pool, then it's obviously going to be cheap. It's much cheaper than any of our competitors. Anyone, I would challenge you. Bring me anyone else. Is a much cheaper solution. SQL pool, and if you're running 100 or 200 SQL pool and MPP system, you can run it at a very cheap solution. Okay. Any other questions?
Yeah. What was the Oracle piece implemented in Azure or from OCI directly?
No, we didn't do OCI. It came from on-prem. It came from OGG. So OGG on-prem to Azure Hub in Azure. And Stream Analytics in Azure.
Then a follow-up to that specific question, was pulling from that Oracle data source an AutoDB or was it non-auto?
It was auto.
Okay.
But we have templates for this. So you do not have to reinvent the wheel. Everyone, there's a lot of people that have already done it. We have templates that we provide, so please do not reinvent the wheel. I do not try to do anything out of the box. Reach out to your Microsoft reps, and if you're not sure, you have my email. Reach out to me. I'll help you out to get to these solutions. This is why you have people from Microsoft to help you out.
Okay, I'm going to stop recording and get ready for the next session.